Hello there, this is Daniele from Toolchefs and welcome to the last video of the Locomotion series. So in this video we're going to have a look at some of the behavior modules that are available with Atoms, and we're going to try to give you an understanding of how they work and also how you can interact with the Locomotion system a bit better. So the first module that we're going to look at is the follow target. We already saw this one in the previous video, but just to give you a bit more information about it. So I'm going to set the goal manually to 500, which means that the target is approximately here. So the agent is jogging and then stopping when it reaches the target. To set up the values, and now the agent uses the locomotion, you can change the parameters here. These parameters are not available in all modules. They're just available in the modules that basically the directional modules where basically an agent is following a target. So you will find the linear velocity minimum, maximum, the negative linear velocity max, and so on. So the first, also you can say to the module if you want it to change or not either the linear velocity or the angular velocity. In this case, for the angular velocity, it wouldn't make a difference just because the agent is working, actually is moving on a straight line. So going back to the attributes here, so the minimum and maximum for the linear velocity, basically just say to this module what must be the maximum value for the linear velocity and of course the minimum value that can be used in the simulation. So 300 is basically higher than the jog, so probably if we just want to say I just want to use the walk, and if you remember before in the main walk we set it to 130. So now we're just saying the walk, use the walk, we set it to 130. The negative linear velocity is basically used whenever the target is behind the agent. So for instance, let's say if we have just one linear velocity maximum, which is basically let's say it was set to 275, which is the jog, then the agent would keep jogging even if it was trying to turn, right? But in some cases, you actually want the agent to go slower if the target is behind, because you want it to be able to turn and maybe stay in the spot. So maybe you might even set this one to 0. Usually 130 is fine. In this case, would mean that the agent can keep walking and then stop and turn, or either just turn, go back while walking. Then we have the locomotion fall-off radius, which is basically a radius where an agent maximum and minimum velocities are blended. So between when it's further than 100, we're using the maximum velocity, and then the value will be decreased until it reaches the minimum. Then here you have a locomotion target distance, which means that whenever the agent is closer than this distance to the target, then you should play the minimum velocity. So now the agent basically will just walk and then stop. So you might want to increase this value so that it's closer to the target radius. So maybe 40 could be a good value. Sometimes it can be the same. It really matters on, it really depends on the simulation. Okay, so now let's have a look at another example. Okay, now let's have a look at the follow curve. The follow curve is different than the follow target because the follow curve is just aligning the agents along a curve, so it doesn't really affect the linear velocity. You can affect the angular velocity, which is what we're going to do here, but for the linear velocity you would have to set an initial value unless you're using another module for driving the linear velocity. So in this example, for instance, I'm pressing play now, the agents are walking, just following the curve. And nothing more than that here. If we check the let's see, if I open and do the bug, let me select one agent so that we don't see all of them. So we see here the main walk left 45 actually has some values, and it's being blended while the simulation is running. So let me clear the selection. But also what we could do is, like for instance, you could change the target linear velocity with an area trigger by providing a blend in of 20 and saying I want now the target linear velocity to become 300. Then your agents will start jogging. Now you see that as soon as the agents get into that plane, they start jogging. Okay, now let's have a look at another example. Okay, now let's have a look at the follow mesh. So here in the scene, here I have a mesh cutter getting that plane as input, and then I have the locomotion, reading again our locomotion asset. So here I'm gonna add a new follow mesh. Here the parameters in the locomotion sections are the same that we have in the follow target, because with the follow mesh you have agents following a target, which in this case are the vertices of the plane. I'm gonna drag and drop the plane with the middle mouse button on the mesh. So now it's connected. If I press play now, the agents are following the mesh. But I think we might see something weird going on at the end of the sim. Yeah, so you see the agents are trying to, basically I think they pass the target, so they try to come back, but then they still need to basically they never reach the target in the end. So what we can do is, first of all, we can set the minimum distance to be 10, which means that whenever the agents are closer than 10 units, then basically this module will stop working. We don't want to do anything else. We're also going to set the locomotion target distance to 15, just because we want the agents to stop before they are within the minimum distance. So basically, when we're closer than 15 units, we'll set the linear velocity to 0, which is the minimum. And so yeah, so now the agents are actually doing what we're expecting them to do. Another important feature about the locomotion asset is that it can be used inside the state machine. So if I open the Atoms UI, state machine, and then call, well actually let's leave the name like that. I'm gonna open the animation dialog here. Gonna import the man walk and man idle. Actually let me do the opposite, best man idle, man walk. So just for the ideas that I did that. So we have the idle at 0, then we have the locomotion. I'm gonna set our locomotion asset, connect these guys. The locomotion here on the locomotion asset, sorry, on the locomotion node in state machine, after selecting the locomotion asset, you can also provide the max acceleration and average num frames for the linear and angular velocities. These are the same settings that you would have on the locomotion module for an agent group. In this case, the state machine doesn't provide those, so you can actually set those directly here on the state, on the locomotion state. So I'm gonna save this one. I forgot to attach it to the agent type. So new state machine, I'm gonna save this one. Then I'm gonna assign state machine module. So when I'm at 0, I'm in idle, 1 is working, and 2 is in the idle state, or in the locomotion state. So what I want to do is I want to say I'm gonna start in idle, I'm gonna get here, I'm gonna switch to locomotion, then I'm gonna go here, and this guy here, I'm gonna go to work. In between here, I want to change the target linear velocity to so from 0 to 130. So the agent will start working, and if everything works as planned, yeah, the agent start working. And then over here, we're back to the work. So if we open the debugger, and if I go here in the state machine debugger, let me show you over here the agent. So now we're in the main idle. Now you see the state queue. We have just put the locomotion state in here. So eventually the two clips will start playing together. Actually, there are several clips playing together and they're being merged. Then here we have the debugger for the locomotion. We should see the red circle starting moving towards the man walk, and then the green circle just lagging behind a little bit. And then eventually we go to the man walk. So now the man walk is also in the state queue. And now we're playing the man walk. So this is a very simple example about how you can use the locomotion asset inside a state machine. But for instance, if you are planning to have your agents working in an open space, and then when they reach a certain location, they have to play a specific action, this is how you can do it. So you can, while the agents are going around, they can use the locomotion, and then when they're stopping in a specific location, then you can change the state to be the state where basically which contains that specific animation clip that you want to play. Okay, so now let's have a look at an avoidance example. So here I have two agent groups. They have pretty much the similar layout, They have a grid layout and a locomotion. I have set up the initial linear velocity. You see the agents are not really avoiding each other, they're just going straight. So we can assign an agent avoidance. Then we can set the maximum angle to 2, so that basically they don't turn that much per frame. I'm gonna set 300 because 400 is a bit too much for this example. And I have I want to make sure that I avoid the other agent group. And then in the locomotion, I don't want the agent to run, to jog, so I just want them to walk at most. And then I want to make sure that whenever the agents have to go back, so whenever the avoidance is telling them that their target is behind them, I want them to stop and then turn. I don't want them to keep walking. And that's how I do it. So then I have to do the same for the other agent group. So agent avoidance. So I set it this one to 2, neighborhood to 300. The agent group here would be the other agent group. And for the locomotion, I set this one to 0 and this one to 130. So again, you can tweak the values. Just for this example, I found that 300 was the best distance neighbor. So value. So let's press play and let's see how it works. So you see now the agents are playing both the unseen clips, but also they're stopping. They're waiting that whenever another agent is going to collide with them. And pretty much like we have an avoidance working, even though at the beginning of the sim you see that here it is a very dense area, but the agents are still not intersecting. Again, really depending on your simulation, you will have to tweak the values of the agent avoidance. Okay, so in this final example, we're going to have a look at the behavior tree and how you can use a behavior tree to tweak the values that are driving the locomotion system. So basically in this scene, what we want to do is like we want to have the agents going back and forth. So whenever they get into this plane, they have to turn back, and then whenever they get to this plane, they turn back, and so on. Here I have created this agent with a grid layout. They are playing a locomotion, and also have set the target linear velocity to 130, so they work. Also here what we want to do is I want to set a metadata called status. It's gonna be of type int, and I'm gonna set its initial values to 0, and also agent creation only, so we don't keep overwriting it. So I'm gonna open Atoms UI to create our behavior tree. I'm gonna call this one back and forth, and I'm going to create first of all some blackboard keys. I'm sure, and actually I won't need the direction, so but at least we need for sure the position, and I need to link it. Then I can duplicate this one, and I want this to be a status, which is the other metadata that I just added. So basically we're gonna access the metadata of the agent directly within the behavior tree in this way. Then we want to expose the meshes, so we need to expose the meshes. So mesh 1, let's call it mesh 1, and this is gonna be a mesh, and I'm gonna expose it. I'm gonna duplicate it, and gonna be mesh 2. Then I'm gonna have the mesh translation 1, and this is gonna be a vector 3, and then it's gonna be exposed. I want to duplicate this one. It's gonna be 2, and then what we want to do is I want to make the scale and 1 and 2. Okay, great. So I think this is all we need for now. We can start building the behavior tree. So I'm gonna first create a repeat. repeat, and it's gonna be repeat forever. It's gonna be optional, so we never exit the behavior tree. Actually, yeah, so that should be fine. I'm gonna build a selector. And then the first thing that we want to do is we want to make sure that we're entering in one of these branches. So I want to create a conditional, and we're gonna say whenever the status, so the value is gonna be an int, and I want to be this to be, no, sorry, this one is an int, it's not a vector 3. That's why it's not showing up there. So status, whenever status is not 2, so we have to invert it. We're gonna check if the agent is inside the mesh, I think. So this one, yeah, so this one is the mesh. Then here, this is the position of the mesh, so mesh translation, and then this is the, oh no, actually, sorry, this is the position of the agent. Then this is translation, and we need the scale. So mesh scale 1 and mesh scale 2. Great. So whenever we're inside this area, I want to do a sequence. And we're gonna say, first of all, I'm gonna set the blackboard key of the status. Actually, let's pick it from here. It's gonna be an integer, and we're gonna set it to 1. Okay. Then we want to set the agent and agent metadata, and here the metadata name is gonna be target. Actually, let me go and pick it from here. So the metadata. So we want that one, which is basically the one that we use for the unsync clips, and this is a double, and we want to set it to 180. Okay. Then we want to wait a second. So we want to wait 1 frame, not a second. And then we want to make sure that this goes back to 0, so we don't keep turning. Okay. Then this is done. What we have to do is we have to make a similar branch. Only that we want to make sure that so this one we set it, oh no, sorry, this one should be 2. So whenever we set it to 2, we don't get into here again. So you see, but then here we say 1, and then we set the status to 1. Actually, that's correct. Again, 180 degrees turn, and then wait 1 frame, and then go there. But I think we just need to change this one to be mesh 2, mesh scale 2, and mesh translation 2. Oh, sorry, this one was messed up. This translation 1. Okay, so if I close this one and I attach a behavior tree, and I attach that behavior tree and see if we got lucky. So first of all, I'm gonna attach the plane, 2 planes, and then I have to make sure that I attach also the right translation. So translate here and the scale here, and then I have to do the same thing for the other one. Translate here and scale here. So let's see if this one does anything. Maybe you got lucky and worked straight away. Yes. Let's see if the other one also works. Yes, okay, great. So yeah, basically this is to show you how you can easily use a behavior tree to tweak the metadata values for the locomotion, and make your agents turn whenever they get into a certain area and so on. And this is all for this video. Thanks for watching.